Good afternoon. Welcome. Can everyone hear me okay? Thumbs up, audio's all good? Excellent, thank you very much. My name's Ed. I'm going to start with a little story. On the 19th of July last year, I went on holiday with my wife, and we stepped off a plane, and this was what we saw. Yes, 19th of July, the blue screen of death day. So firstly, the first problem was, of course, we couldn't exchange currency at the currency exchange. Not an issue. We go to a local cash point, we get cash, we carry on with our day. We go out for lunch. We can't pay for lunch with a credit card because the card processors are also impacted. We're looking at the news, we see flights are impacted. We were lucky to even get there. And the next problem, of course, is we start running out of cash. So we go to another cash machine. The cash machines run out of cash because we're not the only ones experiencing this issue. So now we're hunting around the city, we're looking for another cash point, trying to find one that's got any money left, queuing up for it, and then extracting as much money as we can get, of course, and exacerbating the problem even further. And this isn't a story around ransomware, around data protection. It's a story around the interconnected nature of our systems and how the impact in one place can have a huge impact in other areas as well and be much more wide-ranging. And it's this implications of these wide-ranging impacts and the increasing threats and types of threats that we see that mean it's so important to have a defense in-depth strategy. The goal of a defense in-depth strategy is to provide these multiple layers of protection around your applications and your data. So if one of these layers is compromised, it prevents a threat actor moving laterally, escalating their privileges, extracting data out of your systems. A good metaphor here is like a castle. You want to keep your crown jewels in the center of your castle, in the high tower, in a locked room with guards outside the door. And then you've got multiple layers of walls. So if an attacker gets past one, they've got to get past some more before they can get in. On the outside walls, on the top, you've got archers ready to take on anybody coming near. And those people coming near are going to be slowed down by the moat that you've got outside the castle. It's deep and it's wide. And this metaphor is how we think about security at AWS. And data protection is really at the core of this strategy, and that's going to be our focus for the session today. We're also going to touch on some of the other areas from outside. We're going to make sure that you've got some good understanding of how to protect your crown jewels. You're going to learn about what AWS do to protect your data. You're going to learn about what you can do and need to do to protect your data. We'll hear from Aditya at Skyscanner about how they're protecting their crown jewels. We'll cover some of these wider areas from the defense in-depth strategy and leave you with some clear actions of how you can make sure your data is as safe as it can possibly be. Start with 11 nines of durability. What even is durability? So Amazon S3 and Elastic File System both have 11 nines of durability. If you think about durable materials like steel or stone, if you build something from those materials and you just leave it alone, it just stays there looking exactly the same for a really, really long time. And it's the same with data in these services. But interestingly, the 11 nines number is just from the very first of these points. It's a mathematical model based on the well-understood probabilities of device failure. Hard drive manufacturers, for example, they publish an annualized failure rate, the chance of an individual disk failing over the course of a year. And if we look at how S3 works, we'll focus in on S3 a little more because we talk more about how that service works internally. In S3, we're storing data on enough disks so that the probability of multiple drives failing to an extent that your data is lost becomes infinitesimally small. So we'll talk about S3, we'll talk about the resilience and how exactly that's achieved, and then we'll dive into how we make sure that the data you intended to store is the same as the data we give you back when you read it. Erasure coding. It's a mathematical model invented by Reed and Solomon back in 1960, and it was designed as a mechanism for making sure that a message could be partially lost in transit and still be able to be received. And the way it works is you take a message and you chunk it up into pieces, let's say 10 pieces. And then you do some maths on these pieces to create some parity pieces, let's say another 5 pieces. So we now got 15 pieces, and we send all these 15 pieces, and if any 10 of them arrive, you can recreate the entire message. That's how erasure coding works. And that's how we do things in S3. We're taking these data, the data that you write, we're fragmenting it, we're adding in this extra parity, and we're distributing that across enough drives that the chance of an individual failure impacting you is absolutely minuscule. If this entire device fails, then you can still read all of your data because we have enough parts available. And then we can recreate the missing parts. And when we do that, we're only having to read small pieces from the other drives, the other devices, which means we're not putting lots of load on them, like you might have experienced with traditional RAID arrays, for example. And if we look at this at scale, the scale of S3 is incredible. We're not dealing with spare drives, spare devices. We have spare capacity across the fleet because it's continuously rebuilding because we're having to deal with failures all of the time at this scale. And because we're able to do these rebuilds very, very quickly because of the scale that we have and the fact that we're only having to move small pieces of data around, we can rebuild very quickly. And if you think about the probabilities, again, of multiple devices failing at the same time, the faster we can rebuild, the higher the durability we can provide, in excess of 11 nines. As I said, this scale really is quite mind-boggling. The latest number, we've now got over 400 trillion objects in Amazon S3. And another fun statistic is there's more than 15 million requests a second just to objects with the Parquet suffix. It's quite insane. And at this scale, we're not adding disks, we're adding racks. And we have to be clever about how we do that so that we don't get hotspots. So what we're doing when we're adding a new rack in, we're first loading that up, filling it with cold data from our existing racks, so that when that rack goes into production, it's not becoming a hotspot, it's not overloaded. And this is cloud scale engineering. This is how we deliver virtually unlimited storage capacity to you. As I said though, this is just the start. How do we make sure that what we store in S3, what we return to you when you read data, is exactly what you intended to write? And how do we know exactly what you intended to write? Because we can get bit flips, we can get them in memory and on the network between your client and S3's front end. So for a long time, we've had the ability to generate a checksum of your data and send that checksum into S3 with your data for us to check against. We've recently made this the default. So in our client SDKs now, by default, we're generating a client-side checksum. We're sending that into S3, and we're making sure what we received is what you wrote. Then we're taking the data that's arrived at the front end, we're chunking it up, we're storing it in the back end, we're recording checksums of all of those individual pieces that I talked about. And only then, once that's been done and acknowledged and we know we've got that data stored securely, then you get the 200 response. So by the time you've got this accepts 200 response back, all of that work's done. And this is fundamentally different to how most other storage systems work. Also, when you get that 200 response, we've recently added a couple more lines to it. So as well as us storing this full object checksum, we're returning it to you and confirming what we recorded. And we also return this checksum to you when you read data. And we store this checksum now by default, even if you didn't generate one and send it to us. If you write objects not without a checksum, not using our latest SDKs, then we'll still generate that checksum for you and store it with the data. And we do this on top of the work that S3 is already doing to confirm that what we wrote stays intact and remains available. So we're able to check the checksums of this data in the background. And this is important because devices don't just fail and stop working. They tend to have bit flips. They tend to have intermittent errors. And because we've got this checking happening at the individual part level, we're able to determine more easily what devices have got issues and do something about it. So all of this, fantastic levels of durability, could be happening in one data center with one set of power connections, one set of network connections. durability is not the same as resilience and availability. It's not how we do things at AWS. Here, unless you specify otherwise, we are distributing those parts across at least 3 availability zones, such that as soon as you're writing data, by the time you've got that 200 success response back, it's already stored in at least 3 availability zones and is resilient to the loss of one of those availability zones. And if one's offline, not only can you continue to write data, but you also can continue to read data because, of course, we have enough parts available to do that. And this isn't like data center failover in the sense of how I used to do things on premises, where you can't easily test it. This is built in fundamentally into our operationals. We add hardware a data center at a time. We're adding hardware an availability zone at a time. We're making configuration changes an availability zone at a time. And this minimizes the chance of an unintended bug having an impact that affects an entire region. If you use S3 or EFS today, there's probably been an occasion where that service wasn't using all of our availability zones. And you didn't know because it didn't affect the operations of that service. So we've talked about S3, we've talked about EFS. We also have multi-availability options within FSX, our family of managed file services, and of course within our database services as well. FSX for OpenZFS and FSX ONTAP, we can deploy these with high availability, either in 1 availability zone or across 2. And in both cases, you have an active file server and a standby one. FSX for OpenZFS is our newest FSX. It's designed for super low latency file use cases. It's particularly useful for databases like Oracle and open source databases. We also have a new storage class for it that gives our lowest cost file storage. And diving into how we deliver resilience here, writes are acknowledged into an SSD write log attached to the primary file server. They're mirrored synchronously into the other availability zone into the secondary file server. Before that write's acknowledged. We've also got an optional read cache, and that's mirrored as well, so in the event of failover, your data's already warmed up and ready to go. And then all of this data is stored in our new resilient, regional, fully elastic storage class that optimizes for cost automatically. So that's how we add resilience and availability within a region. What about if you need to go beyond a region? What if you've got compliance requirements that say you need to keep multiple copies of data in multiple physical locations, hundreds of miles apart? That's where replication comes in. And replication needs to be asynchronous so it doesn't impact performance of your applications. EFS has really straightforward replication. A couple of clicks to set up in the console. You can replicate a file system to another one in the same account, same region, different account, different region, doesn't matter. Monitor it with CloudWatch. S3 is similar, but even more flexible. Here you're creating replication rules. You're saying if an object lands in this bucket and meets this criteria, I want to replicate it to this other bucket immediately. And that bucket could be in a different account, different region. You've got S3 batch operations for taking care of replication of existing objects. So you can do this to one bucket, you can do this to multiple buckets. You can spread your data around the world, you can make it closer to your end users. And when you do that, it starts becoming important that you can write anywhere. And now we need bidirectional replication. We need to make sure we've got a full mesh. So wherever data is written, it's being replicated everywhere else as well. And all of this is really simplified by our multi-region access points. With S3 replication, you can determine exactly what data is replicated. You can even have a service level agreement on the replication speed if you need one. So that's durability, resilience, and availability all covered, but there is a lot more to our story. And for that, I'll hand you over to Tom.
Brilliant. Thank you, Ed. So as previously mentioned, my name is Tom, and I am a solution architect focused on our global financial services customers here at AWS. As you would expect, there is a good deal of regulation around financial services and how they need to protect and recover from severe but plausible cyber events. And that's where I spend a good deal of my time talking to customers. But before we dive into security and access controls and how they can help you prevent and recover, what do you think is the most common initial access method for threat actors? Now don't worry, I'm not going to look for a show of hands. I just want you to pick one. If you've got one in mind, did you get leaked and lost access credentials? The QR codes will be available on the PowerPoint afterwards. So what do these credentials look like? Well, they can take the form of long-term credentials. What are these? So these are essentially access keys and security keys that allow access to AWS resources by outside workloads that can't assume a role. So ideally, we would like to retire these. We would like to do something different. So if we think about a human resource trying to access this, we can think about using a federated identity provider and multi-factor authentication where that makes sense. If we're thinking about a machine identity, a public key infrastructure and certificates can also be used. But as Ed has already mentioned, we want to build layers of protection in here, and this is just one element. So we can think about a data perimeter. What is a data perimeter? It is a firm boundary around your cloud assets that help prevent outside access. This is mine. I only want to access it. I don't want anyone or anything accessing it either. That's what we want to do. So then, how do we think about applying this data perimeter? Because fundamentally what we want is trusted identities accessing trusted resources from expected networks. And we can build these into policies. Once we have these policies, we can apply them to AWS organizations, where it can filter down into our organizational units and into our accounts. But we can add even more layers. We can think about resource control policies inside of AWS organizations. These are fairly new, but think of them as a type of identity and access management policy. But the crucial bit here is that RCPs don't grant permissions. What they're doing is specifying the maximum available permissions to resources in your organization. And we'll have a look at an example of how they can be used later on. Businesses are not static entities. Neither should your permissions be. And this is where IAM Access Analyzer comes into the mix. Once we've set the permissions, we want to make sure that we verify access. We don't want overly permissive, that's for sure. But then we need to refine them. And as you can see from the flywheel, it is an iterative process. Think about just your business right here. You have joiners and leavers and potentially role changes in between. You have applications that are onboarded and offboarded, and potentially they change what they're doing in between. How do we make sure that our permissions and our security line up with that? What we also want to think about is separation of the control plane and the data plane. As a storage administrator, I look after the storage service, but I do not have direct access to the data. As a data consumer, I have direct access to the data, but I don't administer the storage. We want to do exactly the same thing here, because I don't believe there is anybody that genuinely needs S3 star on a daily basis. If you do, we're available for questions after the event. But I'm a storage guy at heart, and there's another layer of protection. We absolutely have to have backups. A separate, independent copy of the data that allows us to restore and recover should anything happen to the primary data, to the source data. When the NIST cybersecurity framework got its revamp to 2.0, it introduced this bottom column, govern. But what it also did crucially was refocus its guidance onto recovery. So we know how organizations can protect, but do they know how to recover in the event of a severe but plausible cyber event? Now, it should come as no surprise that for AWS, the answer to that will be AWS Backup. This is what we can use to protect the data and to recover. Now, as you are making your way through this AWS services soup, let me just reassure you that AWS Backup is taking a separate, independent copy of the data so that we can recover the primary or the source data in the event of a malicious or accidental data incident. So how can we build that? Fairly straightforward, as it turns out. So down at the bottom, we have some AWS workloads. We create some recovery points and we store those in a vault. But again, I'm going to go back to what Ed said. We can actually take this even further. So we can take a copy of those recovery points and we can push them out into a vault account and take advantage of AWS Backup logically air-gapped vaults. Now you can see there in that vault account, we're also using AWS Backup Audit Manager. So we can see that our backups are doing what they should be doing. We're not just leaving this to folly, we're going to absolutely check. But what's important here is that red box, just to the right-hand side, AWS Resource Access Manager. Now this is a really powerful thing that we can do with an AWS Backup Lag Vault, which is we can share a restore-only copy of that backup. Now, for those of you that have been to summits, there's clearly a bit of space under that slide for something to happen. So if we follow that orange dot at the bottom of the Resource Access Manager, you should see we've now shared a copy of our backup to a forensic account. What this means is that we can now take that data and we can forensically look into it to make sure, verify, validate that the data inside of that backup is good. You can see our partners at Elastio are doing that here in this account, and then they're publishing those results to the AWS Security Hub. There's one more space, so we're going to follow that orange dot again into a recovery account. In this recovery account, we can now test our standard operating procedures. We can test our recovery processes. We can make sure what we think is going to work actually does work. And the important thing here is that all of this is taking place outside of the production account. And we can put in even more layers of protection. For the Windows administrators out there, I feel your pain, but you should also recognize this screenshot. Snapshots. Super powerful point-in-time versions of the data. And I'll direct your attention to the very bottom bullet point. The ability to recover apps and databases in minutes. So if something bad does happen, we have a very quick recovery and restore point. And we can build on this. With Amazon FSx for NetApp ONTAP, we can now add SnapLock. This makes the data immutable, and for my financial services customers, it ticks the regulatory compliance boxes as well. But, I hear you say, we can go even further. Just a couple of weeks ago, we also announced for Amazon for FSx NetApp ONTAP, the Autonomous Ransomware Protection, ARP. What this allows us to do is, as the data is coming into that service, we are going to use AI-based detection to just look for anything anomalous, access that wasn't happening previously, files that are just suddenly not what they looked like the previous time. And if we spot any suspicious activity, we're going to take a snapshot to make sure that anything happens to that data, we have a very rapid point-in-time recovery. The good news is, SnapLock and ARP are free features of the service. So if you're using this, I recommend you go and take a look. For Amazon S3, we have the if non-match request. Now, this is great if you have a centralized data platform and you want to avoid overwrites. But equally, if you have potentially a bad actor trying to overwrite the data, this will stop them as well. And this can also go hand in hand with Amazon S3 versioning. So we don't overwrite the data with S3 versioning, we create a new version. We don't delete the data, we put in a delete marker. So as far as your S3 consumer is concerned, that data is gone, but it is tucked away, safe and sound on S3. To make sure that our version stack doesn't run out of control, we can use life cycling. But what if someone wants to use life cycling against us? Here are those RCPs we talked about. We can deny the ability to delete those versions, adding another layer of protection to that data. And then we have S3 Object Lock, making those objects immutable on S3. So how to think about using this? Well, first of all, we have to go and enable it. If you have existing objects, you can use S3 batch operations to apply that object lock to them, and you can make it default for all new objects. If we just play this then through a simple timeline, you can see that our object lands and we apply an object lock of governance or compliance mode. Governance mode means that if I have elevated privileges or I am the root user, I can change the object lock on that object and delete it. Compliance mode means not even the root user can delete that object. So please, when you are running your compliance mode POC and you set that timeout to 99 years, don't. Because it is a very interesting and awkward conversation when you do come to delete that object and it really won't delete. May I suggest 120 days? So our object has landed, we've applied our compliance mode object lock for 120 days. And as you can see, the object just traverses 120 days, unable to be deleted. The object lock is then lifted, and here we've just shown it's then available if you want to delete it, or even apply another object lock to it during that 30-day period. Now, wouldn't it be awesome if we could bring a customer on stage to talk to you about all of the things that Ed and I have been through? Well, as luck would have it, we have one. So it gives me great pleasure to announce Aditya from Skyscanner to come and talk about his data protection journey with AWS. Thank you.
Thanks, Tom. Hi, everyone. I'm Aditya. I'm a principal software engineer in Skyscanner. I'm based out of London, and I work across the data and AI platform and tooling tribe. I'm here to talk about the journey we took to secure our data. But first, a marketing pit stop. Hands up if you have heard of Skyscanner. Well, that's quite a lot, but I'm going to do it anyway. So we are a global travel company with a mission to become world's #1 travel ally. We serve over 100 billion pricing per day by scanning over 1,200 partners and serving the users across 180 countries and 33 languages. On to the story. So our journey of securing the data starts with the operational data. There's an excellent talk by my colleague Alex McKechnie that he gave at reInvent last year. And the details of that, you can grab the QR code to know more about it. But basically, it takes all the goodness that Tom talked about AWS backups and secure our operational data into a vault. But what I really want to talk about is the analytical data. So analytical data has different needs. We have around over 15 petabytes of data with 2,500 data sets and over 1 billion objects. You see, if we try to back everything up, it will cost us a fortune. So what did we do? We decided to see what is the most critical data set to us. And we figured out that it's around 2 petabytes and around 500 million objects. So it's a good subset of it. So what was the solution? So before I tell you the solution, I think I need to call out that we are a Databricks heavy. We have a Databricks heavy data lake. And we use medallion architecture. So we have bronze, silver, and gold. So bronze for us are the rawest form of data, which means it's mostly immutable. We do not change it. And to ingest the data from our services and our clients, we have this multi-component service. We call it the trusted data pipeline, because nothing creates more reliability in the eyes of the customer than naming your service trusted. So we have a Databricks writer at the end, and because of the fact that it's immutable, we reuse the concept, we reuse the writer, and we create an in-sync replica in a backup account, and there you have it. We have a backup of bronze directly. Now, for silver and gold, it's a different story, because silver and gold are data sets that have been transformed on top of the bronze data set by applying business logic. And by the nature of it, they are highly mutable. So I'm sure every one of us have gone through those dreaded backfills, changes in the schemas again and again. So there's a life cycle that we need to maintain here, and we need to make sure that this all gets backed up. So for this, we chose Databricks Deep Clone. Not only the Deep Clone helps us back up the Parquet and the Delta log files, but it also manages some of the metadata and also the schema changes for us. So this is how we have the bronze, the silver, and the gold backed up in a backup bucket. But the one thing that I haven't told you is that the backup bucket is object log, but it doesn't have a default log. It doesn't have a default log because Databricks Writer does not play nice with a default object log bucket. It requires a header to be added in a put request call, which it does not add. So we had to be creative. What we did was pretty simple, actually. As soon as we wrote an object on the bucket, on the backup bucket, we used those notifications to process them through a Lambda, and we logged every object individually. And that's how we secured our critical data. And of course, the last one is we have a restore account where we do DRR drills, we restore in the case of an attack, and we use this to run our services on top of it. So this is the story of the 2 petabyte of data. What about the rest of the 13 petabyte? We have not forgotten about that. We have some protection in place for them as well. We make sure that we keep the versioning enabled on S3. We have retention for non-current versions, so we issue soft deletes. We also use the service control policies that limit the lifecycle modifications of the lifecycle policies. And also we are going to explore the RCPs that Tom talked about to limit this from third parties. So in summary, what are the possible things that you can do to protect your data against deletion? You can use versioning. You can issue soft deletes. You can use object lock, governance mode, compliance mode. We'll talk about that in a bit. We can limit the lifecycle permission through SCPs, RCPs. You can change your process, update your processes, require more reviews, and also monitor and take action using CloudTrail. On to the challenges. So you know the case when you say to your customers that only the critical data will be backed up and suddenly everything becomes critical? That's kind of what happened to us. So we started with 400 data sets and with version 1, and now we have 700, as I showed you before. So what we need here is a alignment and a clear definition of what criticality means if we were to keep it scalable. The other problem that we have is orphan files or irrelevant files. So like I said before, silver and gold data sets are highly mutable, so they change. And when the source data changes, the old data gets deleted in the source bucket, or delete marker is put in the source bucket because we do not permanently delete that. But the Databricks Deep Clone, when it copies, it copies over only the new file. It does not copy over the delete markers to the backup bucket. So in the backup bucket, those files which are still current version as per S3, but they are orphaned and they have no relevance for the tables in the backup bucket. So we need to regularly run vacuums on the tables in the backup bucket as well to get rid of this problem. But then this leads to the third problem that we have is the balance between governance mode and compliance mode. Well, Tom already told you about the awkward conversation. If you lock up an object for 99 years on compliance mode and it's irrelevant, then we are stuck, right? Nobody can delete it. So with the problem of irrelevant files, it's very difficult for us to commit to a compliance mode right now and say that, okay, we can lock up our data for 7 years, 3 years, or whatever duration. But we actually have a solution that we want to try out, which has a neat solution by AWS, which is about creating these logs for short duration, but keep extending them. So it uses a combination of inventory, manifest, and the batch operations to figure out which are the logs that are expiring and extend them regularly. With that, I'm going to give it back to Ed to wrap up.
Awesome. Thank you. Thank you, Aditya. I just love how Skyscanner have taken the time to evaluate the different needs of their different data sets and then made use of all the tools available to them to protect that data as much as it needs to be protected in the most efficient way possible. So let's wrap up with a quick look at some services and features that you might want to take a closer look at. There's going to be a few more QR codes to keep your camera handy. AWS config, this is how you make sure services are set up the way that you want them to be. You can assess and audit their configuration and alert if those settings aren't as you want them to be. AWS CloudTrail is for logging, searching, analyzing, and responding to account activity across your AWS organization. You can log management events or also data access events. At a minimum, we recommend you have this set up to log your management events, and then you can set up alarming against those events if they're things that shouldn't be happening. So a common pattern that we see customers having is they'll have an alarm set up if there's a CloudTrail management event that says a lifecycle rule was changed on an S3 bucket. Because if you've standardized, you've decided what your settings should be and implemented those settings, and then they change, you want to know about that. You want to have the opportunity to correct that if it was a mistake before it's too late. GuardDuty is our threat detection service. It's continuously monitoring your accounts and your workloads for malicious activity. It's also got a malware scanner that works across S3 and EBS. And there's a feature in there called S3 protection with extended threat protection. And what that's doing is looking at the activity on your buckets, both the management plane and data plane, and correlating that with other information it has available to it to look for and predict and warn you about potential malicious activity. S3 Storage Lens is how you get a high-level view of what's going on inside your S3 buckets. Zooming in here, we can see current version bytes, % current version bytes. This is looking at how much of your data is a current version and how much is a deleted or overwritten version. If this was 50%, you're storing as much current data as you are data you've overwritten or deleted. So it's an indication that you might want to think about whether you're keeping data for too long. Storage Lens free tier is, as the name suggests, completely free. You all have this in your accounts, you can use it today. If you want to get hands-on, have a play with it, this workshop has some great guidance. It also has the ability to drop a CloudFormation into a test account and deploy some test data to give you an easier learning experience. We also have advanced mode. And if you are using advanced mode, please make sure you tick all of the boxes. You're paying for the number of objects being monitored. You're not paying for the individual features in there. So please turn everything on. And then you get a huge amount of additional metrics. Usage metrics. You can filter on prefixes. You can filter on suffixes. You can filter on size using lens groups. And with our advanced data protection metrics, you can see how much of your data has a current object lock on it. You can see how much of it's replicated. Really, really powerful data in here. And what we tend to find is customers save about 6 times what it costs them for this monitoring. Well, Lens is the high-level view. Inventory is the low-level view. If you want to track and view and audit exactly what's going on with the data in your buckets, Inventory is how you do that, right down to the level of what tier within the intelligent tiering storage class an object's in, whether the object's been replicated or not, and what the retention date is on those object lock settings. So I expect you're thinking, where do I start? Well, the first thing is to have that conversation about what your data requires. Just like Skyscanner, you're going to have different data sets with different protection requirements. You need to think about what the threats are that you want to protect against, what kind of recovery speed you want, what recovery means to you. Would you be recovering to another account, another region? Same bucket, same file system, different file system. These all vary depending on the nature of the event and the nature of your business requirements. Some data is more critical than others. Think about how you build that defense in depth strategy for your organization. How can you protect your crown jewels the best? And once you've decided on those settings for your different data sets and types of data sets, standardize, automate, orchestrate. Don't be having the conversation after an application's gone into production of how should you protect this data. Get that in place up front. And once those settings are locked in, as I said, you want to be auditing and tracking on changes. If changes are happening, why are they happening? Have you made sure you've got reporting against that, alarms against that? And all of this needs to be checked and revisited on a regular basis because things change. AWS are constantly innovating on behalf of our customers. Some of the things we've talked about today were implemented in only the last few months. So this landscape's changing from an AWS perspective, it's changing from a threat detection and a threat actor perspective, and it's changing in terms of what your business requirements are. So you need to regularly revisit it. If you grab your camera and take a photo, you can access any of these QR codes by just tapping on that photo later. There's a few key resources here you might want to have a look at. We've got a couple of hands-on workshops. You can run these in your own accounts, both around ransomware simulation and also getting hands-on with exactly all those features that Tom was talking about in S3. Versioning, replication, multi-region access points, it's all in there. Object lock. A couple of excellent sessions from our big events last year, diving into that defense in-depth strategy a little further. And some more information about config and CloudTrail and how to really make use of those within your organizations. If you don't already have an account on Skill Builder, highly recommend that you get one. Lots of fantastic free training on there. And that just leaves the all-important survey. Please take a second now to scan this QR code. It'll open the app. It's like a couple of questions in there. AWS are really, really data-driven, honestly. We can only bring content like this to you if we can prove we find it useful. Prove that you find it useful. So we really need your support with this, and we will read all of the feedback. If you'd like a copy of these slides, they'll be on my LinkedIn page in about 8 minutes. I want to thank my co-speakers, Tom and Aditya. I want to thank Skyscanner for being so open with their story, and thank you for choosing our session.